Hello everyone, and today we just have a new topic, means we can just call it modern physics. So basically we can see mainly from starting we have been studying about the classical physics. What is classical physics? How can we apply classical physics in our day-to-day life? If my hands are moving, so what kind of classical physics I can apply? If I'm speaking, sound is reaching to you, so sound is captured in the video. So how can we classical physics applied in this? We study many kinds of things, from waves to the kinematics, dynamics, entire mechanics we study in classical physics, thermodynamics we study. So, but we have today an introduction to about what is the modern physics. Because classical physics, if we talk about mechanics section in classical physics, so it is mainly subdivided into kinematics and dynamics. In kinematics, we study motion of particles without studying causes of motion. Just my hands are moving, they're in motion. That's why I can apply some rules of kinematics in this, and actually I can apply many number of rules of just kinematics in my hands when they are moving, when they are just at rest. So I can call the study of objects at rest as statistics. But if I talk about dynamics, so why is it moving? How is it moving? This deals with the dynamics. This studies dynamics, means about the force. What is the cause of motion? That is overall force. So study of force, laws of motion, Newton's laws of motion is known as dynamics. But still in classical physics, it is really a very broad section of physics. But sometimes what happens, classical physics can't be applied. Let me tell you a nice story. That, do you know, at the beginning of 20th century, before the beginning of 20th century, means before the beginning of 1900s, do you know, physicists were thinking that we have discovered overall everything in physics. We have discovered everything in physics. But still in today's day, here we have 2021 has begun, but still everything in physics isn't discovered. A nice example can be a theory of everything, a complete unified theory. Even today, scientists are struggling to find a complete unified theory. Still everything isn't discovered in physics. But before the beginning of 1900, physicists were thinking there's nothing more important left to discover in physics. But later what happened? Then just came a problem called the black body problem. That was really a major problem. Its name is black body problem, and it was really a major problem for the physicists. And this kind of problem had challenged to the physicists. And after struggling much, even physicists had understood what is the solution to this kind of problem. But still, they had, since we know to a very great mind in the history of physics, that was Max Planck. He had discovered the solution for the black body problem. He had solved this kind of problem, but at a cost. He had applied a cost for it, and the cost was quantum. He told the world about the quantum. What is quantum? If quantum doesn't exist, if we neglect the value of quantum, then we can't solve the black body problem. So anyhow, he had to suppose of any kind of, just you can call any packet of energy called quantum. And when he discovered this kind of packet of energy called quantum, so it was really a very great research in the history of physics. Classical physics we deal. So basically Galileo Galilei, Sir Isaac Newton, who are very great mind in the history of physics, they contributed to it. But if we talk about very small objects such as subatomic particles, atoms, molecules, if we talk about neutrons, protons, electrons as entire nucleus, can classical physics deal with those point-like objects? No. Classical physics actually can't deal with those objects. If we talk about objects moving close to the speed of light at a very fast and high speed, can classical physics deal with those objects? No. Classical physics again can't deal with such objects. I am moving, I'm walking. If I walk anyhow like this, how fast a man can move? How fast? Usain Bolt, if he also, suppose any man I have, if he is moving by 1 kilometer per second, so it is very high speed. I do not think anyone can just move any man by 1 kilometer per second. Okay, but still, if any man is walking by 12 kilometers per second, it is very high speed. But in matter of physics, it is not too high speed. High speed means what? High speed means the speed of light. Okay, something. Let me tell you a very important thing. If you want to achieve what you haven't till now, so you will have to do what you haven't till now. That's the point. If you want to become the greatest physicist of the entire history of physics, so you'll have to defeat Professor Albert Einstein, because Professor Albert Einstein has been the greatest physicist in the history of physics. So if you want to be the next, you'll have to defeat him like this. If we want to just compare any object's motion to very fast speed, so we'll have to compare with speed of light. So even now 1 kilometer per second is nothing in front of speed of light. It's just like a sand particle in front of speed of light. What is the speed of light? 3 lakh or 3 lakh kilometers per second. And if we compare 3 lakh kilometers per second to 1 kilometer per second, what will be the point? Okay, that's nothing. It's no kind of speed. But still, for humans, it will be a kind of great achievement. Means 1,000 meters, 10 cube meters per second will be just a great achievement actually. So, with a small speed, our classical physics can easily deal with was just concerned by Galileo Galilei and Sir Isaac Newton and even many other great minds. But basically, those two had greatest contribution and the father of physics and modern physics. But when we talk to very high speed like that of a speed of light, 3 into 10 power 8 meter per second, so a new kind of physics should be born for that, a new kind of physics, and that must be the modern physics. Remember, physics before the 20th century is known as classical physics, while the physics of after the 20th century is known as the modern physics, a new kind of physics. Basically, in physics, we deal with the classical section and modern section. Classical section we have mainly dealt with, but what is special in modern section? It deals with the particles that are really very small, as I've given you the example, electrons, neutrons, protons, those quarks, and even vibrating strings from which quark has been born according to the string theory. But if we want, so through modern physics, we can also deal with particles moving at very high velocity. And if we remove the direction, so moving with very high speed, like that of speed of light. Suppose 99.99% of speed of light is throughout a very great achievement. I don't think still we can achieve such a high speed. Okay, LHC means Large Hadron Collider has achieved a very great achievement. So really, I feel proud that we humans, entire humans are progressing. Because when we look ourselves from the outer space, when we look the earth, so we see ourselves as whole, as unity. So that's really very great achievement of LHC. And then, but still 3 into 10 power 8 meter per second is very great thing, 3 lakh kilometer per second. But basically, modern physics can deal with so high speed. Modern physics can really, because what is light made of? Light is made of photons. What are photons? You can define the quanta for light. So basically, it can deal with photons. Photons are very small particles and even very fast particles. Actually, why light travels by 3 into 10 power 8 meter per second? Because basically, photons travel by 3 into 10 power 8 meter per second. This is the reason light actually travels because the photons travel. If photons would be at rest, light would be at rest. If photons would travel by 2 into 10 power 8 meter per second, so even throughout the light would travel by 2 into 10 power 8 meter per second. Basically, light is made of photons. Okay, still it is good. Modern physics can deal with them. So then what's the problem with modern physics? But actually, let me tell you, modern physics is not as easy as we can look at, as we feel it now. It is really a very difficult branch of physics and really a very confusing branch of physics. Okay, so whoever is studying modern physics, I assure you that many times, at least 100 times, he will be confused, just like me. Okay, I can give you example whenever I study the modern physics such as relativistic mechanics or even quantum mechanics, quantum physics. So really I get very much confused, and as much as I study, if I'm studying less, okay, so no problem, then I can easily digest it. But if I'm studying it very carefully, so I just leave the book. Okay, that's the case. So it's really a bit confusing. So, okay, that's too much jokes. So, actually, modern physics, why it is so confusing? Because actually the black body problem which was solved by Max Planck, he gave a reason for that, that was quanta. Means he discovered quanta, or quanta is the plural form. He discovered the quantum. Why is it? Since we study a major branch of physics, that is quantum physics. So, that's quantum physics. What is quantum in this? This is some kind of packet of energy. Since we hear of the equation E equals h nu, so here E is packets of energy. It is energy. So this packet of energy can be given by this following equation. H is our Planck's constant, and nu, actually it is not V. It seems V, but it is nu. Nu is the frequency of the wave. So we can call that. So, but still what is confusing in this? Basically, modern physics, if we want, we can, okay, modern physics can be still subdivided into many parts. That will be just quantum mechanics and relativistic mechanics. Then what's the problem is still, because quantum mechanics deals with whichever kind of particles we have, that are very small particles, with very small kinds of particles such as subatomic particles. While relativistic mechanics, we know Einstein, the great Albert Einstein, and through he is the author of even many books, and really his books are really very awesome and brilliant, because very great person has written, and his theory of special relativity and general relativity are really very great and confusing theories too, because when this kind of theory we can say was published, was patented, so only 3% in the world existed who could understand really properly the general theory of relativity, and including Einstein. Means Einstein was one of them. So other than Einstein, 2 persons existed only on the earth who could really understand the general theory of relativity. So really a bit confusing theory, that is too. Then general theory of relativity includes the gravitational force. So again, coming back to quantum mechanics, this was developed again by Max Planck as he discovered quanta, because it was really a great revolutionary year. I think 1900, it was 14th of December it was when he presented the quanta by solving the black body problem. And still, okay, honestly, I would like to say that is also my birthday, so I just feel very proud over it that quantum physics was born over 14 December, and as well as me, just in 2009. So again, coming to the point, so later, since still it is very confusing, even Einstein was not able to believe over such theory, because quantum physics challenges the nature of reality, the reality in which we live. It challenges that. Again, I say that it asks such question that can the moon exist when no one is looking at it? Can any kind of, suppose any cell phone we are putting on the table, and if no one in the world is seeing at that cell phone, so will it be there? Will it be the same place as on the table? Listen, those are some strange questions. If Newton would be sitting near the person who is asking this question, Newton would say, yes, obviously it will exist, but quantum physics gives a different answers. Basically, quantum physics is for subatomic particles, so it gives answers about subatomic particles, electrons. Still, in many schools, it is taught that the electron orbits the nucleus as the planets orbit the sun. But to be very frank, I say that it is not the case. Still, it is not the case. It is totally restricted by the modern physics. It is restricted by, we can just call quantum mechanics. Quantum mechanics gives a different reason, a different explanation for this. Actually, the electron does not orbit the nucleus as the planets orbit the sun. It may be possible that under the action of some centripetal force, some kind of force, it may orbit. But according to quantum physics, this is not the case. According to quantum physics, suppose I have 2 points, 1 point here and 1 point here, A and B. So, if if any particle is going from A to B, point A to point B, and here's some point lying between the way, point C. So if any particle is going from here to here, means A to C, B, so it will have to must pass through C, but this is not the case with an electron. If electron is here at some instant, so at some other instant it will be here without passing through this point. That's the quantum mechanics. This is the quantum mechanics. This without passing from the midway, it can reach to its final destination. So that's really very confusing. And I would like to even tell a quotation that for those who have not just confused when they first come across quantum physics, okay, you can call even quantum theory, cannot have possibility understood it. Cannot have possibly understood it. By whom it was said? One of the greatest mind in the history, Niels Bohr. Because Niels Bohr really is a very great and influential physicist, and even Werner Heisenberg has written it a single time, and even he has said that Niels Bohr is the most influential physicist I have seen ever in my life. Even more influential than Einstein. So we can understand his level, what was really his level. So really he is very great physicist, and every scientist, every physicist, whomever you see, I am sure they will be first of all confused when they first hear about the quantum physics. And still, according to me, according to my research over quantum mechanics, I would like to see really that there's no person in the world who would not get confused if he is understanding the quantum mechanics. So there's no person on the earth who would not be confused after reading it. Even Einstein was confused, and if Einstein is confused in this, so what are we? We will also be somehow confused in the quantum mechanics. So basically that's the point. And about relativistic mechanics, we all know Einstein, Albert Einstein, 1905, year was 1905, a revolutionary year for physics, when Albert Einstein, he had done at least 4 patents in the year, 4 patents in a single year. Many physicists take 4 years for one patent, but Einstein had done 4 patents in a single year, 1905, and the 4th was most revolutionary. That was the special theory of relativity, since it give answers to the many questions, even to such question which no one asks. Even it has given answer to such kind of question which is not asked in our day-to-day life. Albert Einstein defined that actually time is not absolute, time is relative. Okay, and he also gave a thought experiment for this, and mathematically also he defined it. You can call by every kind of way he defined it. Time is not absolute. And both Aristotle, Galileo, our early scientists, whole classical physics would believe that time is absolute, but he said time is not absolute. Then, as we know, it was really throughout very great research. Even from then we can even compare Einstein to Sir Isaac Newton, and we can see that they both are really very great mind in the history. If Sir Isaac Newton wouldn't be, so today we wouldn't have the universal law of gravitation, and if there wouldn't exist the universal law of gravitation, so we wouldn't see the face even of general theory of relativity, which is totally based over gravitation. If we wouldn't have idea of gravitation, so we wouldn't have the idea of general relativity, and so great researches wouldn't be done today in the field of physics. So I would not like to compare both of the physics because they are great in their own field. Einstein was in relativistic, you can call modern physics, while Sir Isaac Newton, Galileo Galilei, those physicists were in the field of classical physics or the classical mechanics. As a whole, you can call the physics classical physics, and so on. And as we know, 1915, just after 10 years of the publication of, we can just call the relativistic mechanics of a special theory of relativity, Einstein published the general theory of relativity. Really great research. Since today, how do we deal with the black holes? That's all due to general theory of relativity. And even general theory of relativity was experimentally confirmed in 1919. Okay, that was 1919. What happened during that year? It was confirmed by the solar eclipse that light is somehow bent. Means so high the gravitational force and the mass of the, we can call sun, is that it bends the space-time, and if space-time is bent there, so what is light? Light is bent there and approaches us from a distant star. So later we just had law for gravitation. Since Newton had proposed a law for universal gravitation, the universal law of gravitation, but that was again classical physics. But general relativity we use as the modern physics. We use it as modern mechanics. So basically this is a modern theory which scientists mostly use today. But still we have relativistic mechanics. We can call general theory of relativity for very large objects, and the quantum mechanics for very small objects, for very small particles. But today scientists are trying to combine the two theories to form a single theory. They are trying to unify the two theories to form a single theory that can explain everything, from the very large particles to the very small particles. Some people call that a grand unified theory, GUT, or you can call complete unified theory, or as well as the theory of everything. Since basically we see it was also Stephen Hawking dream to form a single equation that will explain the entire universe, but still he was unsuccessful in that. And even today many physicists are trying to unify the two theories, but still they are unsuccessful in that. So basically maybe, and it is 100% sure, because actually Hawking had predicted that up to the end of 20th century this theory will be discovered, but unfortunately it was not. Then I assure that it is 100% true that this theory will be discovered someday. And which day it will be discovered? It will be very great day in the history of physics. And actually it's my ambition to unify the general theory of relativity to quantum physics. I want to help the scientists in that, and surely as much as I can try, I will surely try to unify the two theories. And basically that's now my ambition, because I want to be a physicist and I want to really be a great physicist, well able to win the Nobel Prize for physics for my country India. And for that I want to unify the two theories. So I assure if I will have any theory, so first of all I will be working over this kind of theory, a complete unified theory. So this was the introduction actually to modern physics. And if you aren't confused even now by reading the relativistic mechanics and quantum mechanics, so I assure you in the next videos you will be surely confused, because it deals with many kinds of such things. Since in our day-to-day life, if two things are opposite to each other, so both kinds of things can't be correct. If two statements are opposite, are opponent of each other, both can't be correct. But in quantum mechanics, everything is possible. Nothing is impossible. If light is a wave, so it is also a particle. If light is a particle, it is as well as a wave. Quantum mechanics, this was predicted by the Young's double slit experiment, Young's two-slit experiment. So I assure my next videos basically, first of all, starting from the quantum mechanics, will be dealing with relativistic mechanics, and there whichever viewer I will have for this, I assure everyone will be confused, because still I say that, okay, I'm not just kidding, I'm not joking, that still I'm much confused still in the quantum mechanics and relativistic mechanics. So as soon as possible I'll clear my all doubts related to it, because still whenever I study those kinds of theories I just get crazy. So I have to leave it just after 1 hour. So basically this was my today's introductory video for modern physics. So thank you for watching this video. Jai Hind, Jai Bharat.